So for the final practice, we are going to make extensive material characterization. Is to acquire all knowledge during the semester in the laboratory of material behavior. This is the equipment and materials that we are going to use. First, we do the tensile test, and this is where the result that we obtain for the sheet and calculate it. We get a stress, yield stress, tensile stress, strain, modulus elasticity, and the percentage of elongation and area. We can see that the percentage of elongation were 22.03% and the percentage of area reduction were 64%. And we can see that we get a yield strength of 61,690 psi and a tensile strength of 80,940 psi. These were the result sheet that the machine gave us. The metallographic process starts with cutting the piece, then we encapsulate it and mark it. Then we do the sanding and polish process, where the sanding we use a sanding paper of 120, 240, 320, 400 and 600 by 3 minutes at 200 RPM. Then we do the polish, that is going to be a clear view. Next, we put it in the microscope to see all the grains. We use the mag of 100, 500 and 1000. We can see the results. We can see in the first image the 100 view, the next image is the 500 and the next the 1000. We do analysis for the 500 and we can count 130 grains and a HTM grain size of 11. The next process is the hardness test, all the hardness tests. The first one was the Mobius automatic. We do it 2 times and we get an average of 208.5 HP. Next we do the Vickers manual to compare it with the automatic, and we do it 2 times and we get practical hardness of 207 HP. So it's not very different with the Vickers automatic. Next is the Brinell. So we do it 2 times also and we get a practical hardness of an average of 3.6 of the diameter and a practical hardness of 235 HB. And the result theoretical were 284, so we are not so great. For the rope well, we use 150 kilograms and we do it both times and we get an average of 40.5 HUR. For the impact test, we do it in a room temperature that were 25.8 Celsius. And the energy absorbed by the piece were 68, but we had to rest the calibration that were 5.5 and the result were 62.5. So the type of the fracture were reductive. This is a comparison of the theoretical and practical data. We can see that the percentage of the elongation is now out of the range, also the modulus, the Vickers and the Brinell, but we are not so a part of the theoretical results. This could be for the room temperature, for the ambient or other experiences that we're doing in the moment that they do the theoretical. For conclusion, for all the machines and processes we made in the semester, I think I like more the metallographic ones, because you start with a specimen and transform it to specimen to analyze, but with a long process between the end and the start of the pieces. Also, I think that the universal machine are the most used, because it's the best to start in every analysis of material. With this semester in the laboratory, I acquired all the knowledge of every machine and process used, to elaborate myself other practices, and to know which tests are better for each material. I really like that we only learn theoretical things. I like to see what we learn in class by making it in the laboratory, but I don't like that this semester in the laboratory were closed half of the day some days, but in general I enjoy it.